Hello, my fellow mathematician. Welcome to Calculus 2. Calculus 2 is about integral calculus, and the prerequisite is Calculus 1. It is practically impossible for anyone to really comprehend Calculus 2 without the knowledge of Calculus 1. Now, in my YouTube channel, I have done all the concepts which are needed in Calculus 1 through my YouTube channel name, which is Luke Aaron, as indicated here. So kindly consider typing on the YouTube channel Luke Aaron 1, so that you get all the details on Calculus 1 in steps method which are easy to comprehend and understand. So today I want us to calculate to check how do we integrate even powers of trigonometric function. In this video tutorial, I'm going to take you through these 6 even power of trigonometric function. Most of the time on the table of differential, of course, they are the result there. You are given the result of all this. But many of the tables, they don't give you the process on how to obtain the result of this. So that is the purpose why now this channel exists. I remember even during my days in the university, I kept on wondering where these were obtained. And of course, I just crammed them. So to break that gap, that is why now I came up with this channel, so that you cannot just pick the result without necessarily knowing where they come from. In case you are given something slightly different, you cannot really figure out. So in this channel, that is what we focus on. So let us start with the A and B, they are related. C and D, they are also related. And E and F, they are related. So we start with A. How do we integrate tan squared of x dx? Now to do this, we are going to need this is the identity we are going to make use here, that sine squared x plus cos squared x is equal to 1. Is equal to 1. Then tan squared x plus 1 is equal to sec squared x. What I have done, I have divided by cos squared x both sides. So in our case here, we have tan squared x. So tan squared x is equal to sec squared x minus 1. So instead of tan squared x, I'm going to substitute it with the sec squared x minus 1 everything dx, which is equal to, now I can distribute the integral sign. This is sec squared x dx minus integral of dx. Now from differential calculus, sec squared x is tan squared x. So I mean is tan x, sorry. Integral of dx is x plus constant c. So we have dealt with A. The integral of tan squared x is given by tan x minus x plus constant c. That is the result. So we go to part 2. Part B. Part B, we have integral of cot squared x dx. This one, we are going to make use of this identity. The identity which tells us that cot squared can be written as cosec squared x, cosec squared x minus 1 everything dx. There is also a full video on which I have shown how we obtain all these identities. Then we distribute the integral sign. So cosec squared x dx minus integral of dx. The result will give you cot of x minus x plus constant c. So we can clearly write here that the result here is cot of x minus x plus constant c. So we are doing well. Now we go to part C. Part C, we are integrating cosec squared x with respect to dx. So how do we do this? Actually it is important because it has your hand here. Maybe you are wondering how have you obtained this. We let our u to be equal to cot of x. Then our du will be given by cosec of x squared. Cosec of x squared. So this can be written as du. Of course, there is a negative here. Negative. This is dx. So negative outside. Which is equal to negative u. But our u is equal to cot, which is equal to negative cot of x plus constant c. So meaning that integral of cosec squared of x dx is equal to negative cot of x plus c. Part D, this was c. So we have obtained our result here as negative cot of x plus constant c. Part D, integral of sec squared x dx. Here we are going to let our u be equal to tan of x. Our du is equal to sec squared of x dx. So we substitute sec squared x dx is du, which is equal to u plus constant c, which is equal to tan of x plus c. So the integral of sec squared, this is part D, meaning that integral of secant squared of x dx is the same as tan of x plus constant c. So we can write our result here. This is tan x plus c. And finally we go to number E. We are to integrate cos squared of x dx. Here we are going to make use of this identity. Half into bracket 1 plus cos of 2x dx. This can be written as integral of half dx plus integral of cos of 2x dx. So there is also a half here. Half that. So the first part here, it is x over 2 plus half integral of 2x dx. So to integrate this, we are going to let u to be equal to 2x. Then our du is equal to 2 dx, meaning that our dx is equal to half du. So integral half multiplied by half integral of cos of u du. After substituting here with the u, 2x with the u, and the du and the dx with half du, we are going to obtain that it is equal to 1 over 4 multiplied by sine of u plus c. Integral of cos of u is sine of u, meaning that integral of course this is equal to 1 over 4 sine of 2x plus c, meaning that integral of cos squared x dx, the result is equal to half x over 2 plus 1 over 4 sine of 2x plus constant c. This is the result of, so this is part E of our consideration. D, you are going to, F, you are going to integrate sine squared x dx, which is equal to, we make use of this identity, integral of half into bracket 1 minus cos of 2x dx. Now, there is a video tutorial which I have given on how to transform the angles of sine squared x, cos squared x. So you can check that to obtain the result on how these are transformed. Here we distribute the integral sign and the dx sign inside to get integral of half dx minus half integral of cos 2x dx. The first part here, we start with the first part. There we can take half outside. This will give you half x. This the other part here. The other part here, this one, to integrate that, we are going to let our u be equal to 2x. Our du will be 2 dx. Du over 2 will give you dx. So 1 over 2 integral of cos of 2x dx is the same as half integral of cos of u, substituting u 2x with u du. The result here is, of course, remember to multiply by 1 over 2. This one for the du. 1 over 4 sine of u plus constant c, which is equal to 1 over 4 sine of 2x. 2x, it is the value of u, substituting it back there, plus c. Hence, integral of sine squared of x dx is given by half x minus 1 over 4 sine of 2x plus constant c. So that is how we obtain those. So that is how we obtain those integral in those simple steps. So the first thing we are doing here, we are making use of this identity. Sine squared x, the power identity, it can be substituted with half 1 minus cos of 2x. So that is what I have done here. And on how this is obtained, you can check it in my YouTube channel and you are going to get it.